All right, mathletes, here we go. 2.3, solving system of equations by substitution and elimination, a personal favorite of mine. All right, so just to start off, let's talk about a solution or an ordered pair in a system. So we're always going to have our ordered pair be an xy coordinate. And what that's going to mean is that x and y are going to be able to be plugged into both equations and work. All right, so we'll get our answer as an xy, and then we'll be able to say if I plug in x and y, it will be true on both equations, not just one. You're going to have a couple special cases here. When graphing, you're going to see this end up being the exact same line. So we know that 3 does equal 3, right? And x equals x, right? They're the same thing. So that means we're going to create a same line when graphing, and this is going to be called infinitely many solutions. So if you're solving and you end up equaling 7 equals 7, you'll know that you have a situation where it's infinitely many solutions, but our shortcut to writing that is just our infinity symbol. The next special case is here. 10 obviously does not equal 12, right? So because that is not true, you're going to create parallel lines. And the reason that's happening is when we talk about graphing a solution, the solution happens where the lines intersect. So if 10 does not equal 12, those lines will never intersect. They'll be parallel because there is no solution. And the shortcut to writing that is a 0 with a slash through it. So those of you who think that just means 0 written in a fun way, it does not. It means no solution. All right, we're going to talk substitution first, then we'll jump into elimination. So substitution, essentially what you need to do is you need to get one variable alone. So solve one equation for a variable. And then we're just going to substitute it into the other. So if I know that x equals something, I'm going to replace the x in the other equation and solve out for y. And then once you get that other variable solved out for, you'll just go ahead and plug that back in to the first equation. So let's look at an example of this. I don't have any variables already solved out for me, but when I see this and there's no number out in front here, that's my easiest one to solve for. So if I add 2y here and get rid of it and add 2y over here, I now know that x is equal to 17 plus 2y. And I can now take that, what x is equal to, and replace it in my other equation where x is. So I'm going to go ahead and I'm going to take this -3. Well, I know what x is, so I'm going to put some parentheses. Minus 4y equals -1. So notice we're using the other equation here. And I'm going to take what x is and substitute. So now we have all y's in this equation, and we can use our algebra skills and solve for y. So when I distribute through here, we're going to get -51 minus 6y minus 4y equals -1. And then we can combine our like terms. So -51 minus 10y is equal to -1. Then we will do the opposite here, add our number. We'll get -10y is equal to +50. And then our finale, divide by the number linked to the variable you're solving for, and we'll get y is equal to -5. Okay, so if I know that y is equal to -5, I can already start to make my answer here because I know my y value is -5. So now what I'm going to do is I'm going to go back to where I had this equation here, and I'm going to plug in the y we just found. So we're going to go back to that first equation and plug in our y. So I'm going to move this over here. X equals 17 plus 2y but instead of y, we're going to use what we just solved for and put in a -5. Now, if I can put this into my calculator, and I definitely can, we'll do 17 minus 10, so x is 7. So there are two separate parts, and we're going to go ahead and put that into our x position. Remember, x, then y. And this is your final answer, okay? These are your way to get to your finale. Right here, we're looking for a coordinate. So pause this and see if you can try it on your own, and then we're going to go ahead and go over these ones as well. So on this one, I'm really stinking close to being able to get a y equals that I can plug in. So I almost have my variable by itself. So I'm going to take this negative, and I'm going to divide everything by a -1. And that's going to get us positive y is equal to -2x plus 2. Now we can use this equation. And we're going to go ahead and plug it in to the y in our other equation. So we're going to have 5x plus 6y equals -9. Except for our y is going to be this isolated amount of content, -2x plus 2. So now you can see we only have x's left. And now we can solve for our x. So in the other one, we found y first. In this one, we're finding x first. It really doesn't matter. You want to find the quickest way there. So we want to use what's available to us. We're going to end up finding both. So we'll have 5x plus, 6 times -2, so minus 12x plus 12 equals -9. Find our like terms. So that is -7x plus 12 equals -9. Subtract our constant in this case. -7x is equal to -21. And divide by the number linked to x. And x equals +3. So again, we are halfway there. We've got 3 in our x position. And now we just need to find our y. So we can go back to that first equation we used, and we could even use this one too. It just has a little bit more solving that you'll have to do with it. And we're going to plug that x in. So we're going to say y equals -2x plus 2, but now we know that our x is 3, and y is equal to -6 plus 2, so -4. And then we'll put that over in our y position. And that's our final answer there. All right. One more example of solving with substitution, then we'll jump to elimination, my real life personal favorite there. Oopsies. So looking at this one, we almost have a variable by itself. This y is super close. Remember, I wouldn't want to solve for x because I would have to divide by the 7. And I want to find the easiest way there. So I'm going to subtract 7x. And now I have y alone is equal to -4 minus 7x. And now we can substitute for our y into the other equation. So 56x plus 8y equals a -32. And we know that y is this, so that's going to go in here. And then we'll solve. 56x comes on down. 8 times -4. 8 times -7. All right. So now watch what happens here. When we combine our like terms, 56x minus 56x is 0x minus 32 is equal to -32. Well, we don't need to put down our 0, right? I don't need to tell people that we have nothing of whatever it is, right? But now look what we have. -32 equals -32. That is true, and we have nothing to solve for right now. And so remember, that comes up to our special case right here where I have negative 3 equals negative 3. So in this case, this would be our answer. And again, as a reminder, this means infinitely many solutions. All right, let's check out elimination. So elimination, what you need to have set up is we're going to kind of manipulate the equations just a little bit by multiplying all the way through in order to make the variables so they can be eliminated. And we remember when we're eliminating anything in math, it has to be the same but opposite signs, right? So I want to see something like 5x and negative 5x. That shows that we can eliminate, right? Because that's going to add up to 0. So then we're going to add or subtract to eliminate one of these variables. And I'm going to make a little note about a trick here, and then we're going to solve. So when I add the equations, my variables have to be opposite signs. For example, we have to have negative 3x and a positive 3x. If they have opposite signs, they will add up to 0. I would subtract my equations, which I always make my equations so that I add them, so that I never forget which one I need to do. So you'll see me add my equations 90% of the time. But if I wanted to subtract, they would always have to have the same sign. For example, if I had 7x and 7x, I know that I can do 7 minus 7, and that also gets to 0. Or if I have negative 7x and negative 7x, negative 7 minus a negative, remember that turns into a positive, so that goes negative 7 minus a negative is the same thing as negative 7 plus 7, which also gets you to 0. So that's just a little trick to keep a lookout for. But like I said, I always try to make my equations so that I can add them because it's a little easier for me to remember what I'm doing here. So I'm looking at this equation. My 3 and my 4 are not the same number, so I can't eliminate those. Ooh, 2 and 2, that works. And I've got opposite signs, 1 plus, 1 minus. So that means I can add my equations. That's going to eliminate these because 2 plus a negative 2 is 0. Then I'm going to do 3x plus 4x is 7x equals, don't forget to add these as well. 4 plus negative 18, so that's negative 14. All right, now we have the best thing ever. This is why I love elimination, because it's just a little one step after that. And we've got x equals negative 2. So now I'm going to do the exact same thing I did before, except for we even have a little bit more freedom. We can plug this into any equation that we want because we haven't really manipulated any of them. So you just pick whichever one looks easier. I'm going to choose the top. 3x, but instead of x, we've got negative 2, so we're still substituting. Plus 2y equals 4. So notice I used the original equation. And so now I have negative 6 plus 2y equals 4. And we've got a friendly two-step equation in front of us. Add 6 on both sides, 2y is equal to 10, and then divide. And y is 5. And so now we have our coordinate, negative 2, 5. Okay? So looking at this one, all right, what we have set up, we got to find matching numbers with our variables. So these do not match. These ones do match, okay? We don't have to eliminate one variable before the other. It's just whichever one is more available to us. So these ones match, but they're the same sign, okay? So I'm going to show you an example of subtraction. Because they're both addition, we'll subtract these equations. 5 minus 5 is 0. 3 minus 2 is 1x, or we can just say x is equal to negative 16 minus negative 9. So that's really negative 16 plus 9. All right, and so that's going to get us negative 5. Oh, sorry. I'm losing my little mind. Yeah, 7. Sorry, guys. All right, so we got negative 7. All right, so that gives us our x value already. So we can go ahead and identify that x value. And then we can go ahead and pick an equation that seems easiest for us and plug it in. So I'm going to pick the second equation this time. So 2, and instead of x, I'm putting my negative 7 plus 5y equals negative 9. So that brings us to negative 14 plus 5y equals negative 9. Add the 14. 5y is equal to 5. And then divide by 5. And y equals 1. So we could have absolutely done that exact same problem with addition. And that's probably what I would have done, is I would have just taken this problem from the beginning and I would have gone, all right, I'm going to multiply one of these by a negative. So I would have changed the sign, changed the sign, changed the sign, and then I could have added. And that would have canceled. We would have gotten positive x is equal to negative 7 again. All right, so we would have gotten the same thing. I just like to add my equations so I know I'm doing the same thing every time. All right, so this one, here we go. All right, here's a good one. That's not the same, and this isn't the same. So we actually can't eliminate right yet. We have to make it able for us to eliminate. So what we have to do is find a factor that we could make both of those numbers. So can I multiply 3 by anything to get to 7? No. Can I multiply 7 by anything to get to 6? No. We ask ourselves the other way back. Can I multiply 7 anything to get to 3? No. 6 anything to get to 7? No. So what that means is I have to multiply both equations by a constant number that's going to make them line up. So I might just choose 3 and 7, right? And if I multiply 3 times 7, I'll get 21. And then I'll multiply this 7 times the 3 to also get 21. So I'm going to multiply through by a 7. And I like this because I got a negative and a positive. So we got opposite signs. So now we'll have negative 21x minus 49y equals 7 times 25, negative 175. All right, so notice I multiplied that 7 to every single number, even this one. All right, so I got to make this 21 match up. So that means I'm going to take this equation, and I need to get to 21, so 7 times 3. And now I'll multiply that through. So now I've got a positive 21x. Love it. I got same number, opposite signs. Positive 18y. We don't really care about these because we're canceling out our x's. And then negative 42. So now I have some equations I can work with. I can add these up because I've got the same number, opposite signs. And those 21x's are going to cancel. So now I'm going to have 18 and negative 49. And that's going to give me a negative 31y is equal to negative 217. And then we will, so remember when I'm going negative 175 plus negative 42, throw all that in your calculator. So negative 31 we're going to divide by, and y is going to be equal to a positive 7. All right, so now same thing. I'm going to take that 7 and plug it in for a y, and I'm going to solve for my x. I can plug it into this equation, this equation, this equation, or this equation. They're all going to work in this case, okay? They're all going to work. They're all the same equation. Even this one was just manipulated by multiplying by a constant. So I'm going to go ahead and just choose the first one. So negative 3x minus 7 times y, which is 7 in this case, is equal to negative 25. So now I've got negative 3x minus 49 equals negative 25. Add 49. Negative 3x is equal to positive 24, and then divide by negative 3, and x is negative 8. So we're using a lot of the same skills with substitution and elimination, all right? But they're both going to be helpful in different ways. So here's a couple ideas here. When am I going to choose substitution, and when am I going to choose elimination? The first thing is if x or y is already by itself. We want to use substitution because it's already kind of set up for us. The next one is if x or y doesn't have a coefficient. So we want to make sure that we can find one that doesn't have a coefficient so I don't have to divide at the end. Because if it doesn't have a coefficient, then we can just take the other variable and subtract it or add it to the other side. And that makes it really quick to make x or y be by itself. Now, when I'm doing elimination, I need to take note of when a variable's coefficient matches. So if you have an x on both equations that are both 7s, that's probably a good sign that we can use elimination pretty quick. Even if we just have to multiply a negative through in order to make them opposite, that's totally fine. And the next is just the actual setup of it. So if you see your x's here and your y's here equal to a number, and then your second equation also has your x's stacked with your y's equal to a number, that's always a good setup to use elimination, because exactly how we did on this last example 6, we can always take those two numbers and just multiply the equation by the other number, and we'll always end up with the same factor. All right, so I hope that helps you guys, and make sure that you're asking us questions as you're working, and enjoy 2.3 practice.